All right. So like I said, where we're headed next, inequalities, and we'll kind of ease into it. Most of this stuff should be just some nice review for you. Okay, and so some of the things that we're going to get into today, and we'll add things later. But we're going to talk about how to write inequalities, how to graph them, how to identify solutions, which is part of the reason why I did what I did for the warm-up. Okay, and then we are going to talk about solving them, but just through the use of addition and subtraction. We'll worry about division and multiplication later, and if you don't remember why, you'll figure out why pretty quick, and if you do remember why we want to separate them, you'll understand. Okay, and they're the standards we're going to hit. Some vocabulary. Guys, we're still stockpiling terms that you want to make sure that you remember. Okay, first is the solution of an inequality, and we talked about this already. Any number that makes the inequality true. So any number that you can plug in for that variable to make the inequality true. And then we'll still use the idea of equivalent inequalities, just like we use the idea of equivalent equations. And so as we solve, that's going to be our purpose. Our purpose is to maintain or to create equivalent inequalities, but to get it down to a form that we can do some things with. Okay? So again, we're going to have non-calculator portions of our test for a while, so we need to make sure that we're up on our vocabulary. All right? Now, writing inequalities. Right? Write the following inequalities, and it can get a little tough sometimes. But if we wanted to represent all real numbers less than or equal to -5, okay, we need symbols. What symbol can we use to represent all real numbers? Sure. Less than or equal to. Just your less than or equal to sign, right? And then -5. Piece of cake. No problem, right? Any major issues there? Try this guy. That's exactly it. X minus 5 is greater than or equal to 23. Okay? Yes, question.
What happens if you write it the other way?
What do you mean the other way?
Like if you put 23 is greater than or equal to X minus 5.
Then it would be wrong, right? 23 is greater than or equal to X minus 5. It's not the same thing as X minus 5 is greater than or equal to 23, right? Which one's bigger, the X minus 5 or the 23? And so what you've done is you've changed the meaning there, right? Now, just be careful, because there's this phrase less than in here. And throughout a lot of the other classes, I keep getting people wanting to put the less than symbol in here. Okay? You don't want to do that. 5 less than a number. We're going to literally count 5 down from a number. So we don't need a less than sign there. Okay? 5 less than a number. So this part is greater than or equal to 23. And I keep saying, and I think a pretty good red flag here is the word is in front of your greater than or more than or less than or whatever. We'll let you know that that is where your inequality symbol should come in. Okay? James did a nice job here. Okay? Just be careful. Words less than and more than could mean subtraction or addition, or it could mean less than or greater than as far as the symbol goes. You got to make sure you can tell the difference. Okay? Got one more to try here. Yeah, and that looks great. So 3 more than. The product of a number and 14 is less than 45 should look like that. Now, addition, can you flip-flop the 3 and the 14x? Sure, addition's okay. But there's that phrase more than, and more than and less than, you want to make sure you flip-flop your terms to make it make more sense. Less than gets you in trouble. But since we're actually counting 3 more than something, we don't need the greater than symbol, right? And then the product of a number and 14, we typically write like this, right? Instead of, I mean, you can put parentheses around the 14, but we generally speaking, we don't. Okay? Is less than 45. Okay? Any major issues, questions there? Okay. Now, solutions. We just talked about the solutions of inequalities also, right? If I want to know if a value is a solution to anything, then I'm going to want to plug that in for the variable and see if I get a true statement, whether it's an inequality or an equation, either one. So to determine if a value is a solution, substitute the value into the inequality, right, for the variable. We still have some issues with people not wanting to actually plugging it into the variable. That's where we want to put it. If the inequality is still true, it's a solution. If it's false, it's not a solution. And so we'll have to make sure that we're paying attention to what the inequality says. Okay? So for example, if we have inequality 2x plus 1 is greater than negative 3, is negative 3 a solution? Well, to find out, we want to literally take negative 3 and plug it in for x. So 2 times negative 3 plus 1, is that greater than negative 3? Oh, plus 1, there it is. Right? 2 times negative 3 is negative 6. This is negative 5. Is negative 5 greater than negative 3? Then is negative 3 a solution to that inequality? No. Okay? That's what we're going to want to do there, to check to see if that particular value is a solution. And we don't have to worry about going through and solving anything just yet. Just plug in the value and see if it works. Okay? Now you try. Let's see if negative 1 is a solution. Okay, we're going to literally plug in negative 1 for the x. 2 times negative 1 is negative 2. Negative 2 plus 1 is negative 1. Is negative 1 greater than negative 3? No, it's not.
Yes, it is.
Yeah, it is. Negative 1 is greater than negative 3. Okay, so this is definitely a solution. Negative 1 is definitely a solution to that inequality.
I got that right, and I didn't put
So when we're graphing, we're showing solutions. And this offers up one way to do it. And I'll talk to you about a different way to do this if you prefer. I don't care which method you use. Pick one that you like and run with it. But as an example here, just so we can write this out and make sure that we're understanding what the steps say, not to be the next example in your notes. But let's say we're trying to graph x is less than negative 8. Okay? Yeah.
Is this like the stuff where you like circle it in, like if it's open and
Right. Yeah, we'll get to all that. Yeah. Okay? So, to graph our solutions, to show all of our solutions, we're going to start with a number line because all of our solutions are all real numbers that make this inequality true. So to show all real numbers, we need to start with a number line, the real number line. And this suggests you put negative 8 in the middle, and then you need to show an integer on the right and an integer on the left. So you need to show the next smallest integer, which is negative 9 to the left, the next largest integer, which is negative 7 to the right. Okay? Now, we're coloring, right? This is elementary school again. We're coloring. That's what graphing inequalities is. We're coloring. Okay? So, we're going to color in the solutions. Right? Is negative 8 a solution to that inequality? Is negative 8 less than negative 8? No. So do you want to color in negative 8? No. So then we want to circle negative 8. We want an open circle at negative 8. Okay? Now, a lot of different ways to do this. The easiest way to do this is just to read the inequality. X is less than negative 8. Where are the numbers that are less than negative 8? To the left or to the right? To the left.
Is this for number 6?
Okay, no. Okay. So X is less than... Yeah, the question was... Okay. So the question was, can you also do this by placing the 0 in here? Yeah. And the answer is yes. And that's how I was always taught. I was always taught to label your 0, right? And then put negative 8 in your graph. Well, negative 8 is obviously going to be over here to the left, right? And then really that's all I need. As long as I understand that you understand where negative 8 is in relationship to 0 and then which way you need to shade because of that, then that's fine. So now we need to go x is less than negative 8. We're still going to put an open circle on negative 8 and then shade to the left. So either method's fine. I don't really care which one you like better. But this one is the way I was always taught. You'll probably see me do this more than anything else. Right? So if we're going to graph the solution to inequality x is greater than 5. X is greater than 5. And again, I don't really care if you put the 0 in there or not, or if you go the other route. I'm going to do that. Put the 0 here in the middle. 5 is going to go to the right. Open or close circle. Open. Right? And then are we going to shade to the right or to the left? To the right. Okay. And so there you go. Yes, question.
How do you know whether to shade in the circle or not?
We got a couple more here. Try this guy. Right. Does your graph look like this? 0, and then negative 8, and then open circle, and then to the left. Okay? It should be like that. All right, you got another one. Try this guy. Does your graph look like this? Right? 0 here, negative 4 over here, or negative 4 in the middle with negative 3 on the right-hand side, negative 5 on the left-hand side. That works too. And then we want everything greater than negative 4. Okay? Same thing. Read it variable first. Q is greater than or equal to negative 4. That means we want everything greater than or equal to negative 4. Okay? Another great question has come up. Do you have to color in the arrow? And the answer to that is yes. If you don't put the arrow, then what you're telling me is that the solutions stop at what? 2, 3? They don't stop there. They go on forever. Okay, so make sure you include the arrow. All right? Good? Next one. Graph the solution to g plus 2 is greater than or equal to 6. There's a little bit of a problem there. The problem here is you may try to start your graph at 6. That would be wrong. You don't want to do that, right? Okay? Now, so you guys already know what you should be doing. But in order to try to figure out how to graph those solutions, we can create an equivalent inequality that has the same solutions, but it's a little bit easier for us to graph. And we do that the same way we created equivalent equations before. And it's all for the variable, right? Just isolate the variable. Just like we were doing before. So we're going to subtract 2 from both sides to get that g isolated. And you're right. We're going to end up starting our graph at 4. Okay? So, 0, 4. Open circle closed?
Close.
Closed. Left or right?
Right.
Wait, did you divide this? You subtracted 2?
Left. We go left.
That doesn't make sense.
Oh, wait a minute. I flipped the inequality sign. Yep, sorry. Mistake. I flipped the inequality sign.
Right, not left.
Okay.
I thought you were supposed to be the math teacher.
Okay. And we're going to go to the right. I'm less than perfect sometimes. But just sometimes. Okay? Yeah, we should go to the right. Okay? Any major issues there? And try that guy. Yours look like this.
Yes.
Okay, so we're going to start our graph at 7. Open circle or closed? And left or right?
Right, left. No, it's going to the left.
To the left. Because that inequality says that m is less than 7. M is less than 7 means I want to color everything that's less than 7. Okay? Read the variable first. Okay? Any other questions there? Got another one. Try that. Does yours look like this? Show your work. Show your work. Okay? So graph this. And so your graph should look like 0 here, -5 here, open or closed? Open. And we should be going to the right. Okay? R is greater than -5 means we want to color all the numbers greater than -5. Okay? All right. We also want to be able to come up with inequalities to help us model some situations. Right? So for example, to play in McDonald's Playland, you must be under 6 years old. Okay? Let's write an inequality.
Is that true?
Let's write an inequality to represent that. Right? We need to find some way to represent the age of anybody that walks in the door, right? Yeah, go.
X is less than 6.
Yeah. But what's X stand for?
How old you want to walk in the door? No.
No,
That's sick.
no, not height.
Anything above 6.
What's X stand for?
Age.
Age. Right? What's X represent? You always want to define your variable. Right? And it's less than 6, not less than or equal to, because you have to be under 6. Okay?
No, that. I still.
Got another shot. Question?
Yeah.
Try this one. To ride the mammoth at Holiday World, you must be at least 48 inches tall. Okay? At least 48 inches tall. My guess is it's pretty close to that.
So wait,
Okay? Right? What's that going to look like? James, what you got?
X is greater than or equal to 48.
And X stands for?
How many inches you must be?
Or said a lot shorter?
Height.
So it works. Height. Okay? And so X is greater than or equal to 48. Okay? Greater than, not less than. Got a lot of less thans before. Greater than. Okay? Got a number line here, so might as well graph it. So 48 goes here.
we have to graph this.
Sure. Open or closed?
Close.
And we want to go to the right. Okay? All right? So if we can recognize this, then we can start to use inequalities to help model some different situations.
I don't like you.
Okay? For example, number 14, an amusement park charges $35 for admission and 75 cents per mile. Per mile. Per ride. Okay? You go to the park with $60. Write an inequality that represents the number of rides you can go on. And then the question, we want to answer this question. What is the maximum number of rides you can go on? Right? All right. To come up with your inequality, how much money can you spend? $60 or less. It's okay. You don't have to spend all $60, right?
Yeah.
So our inequality starts there. I've got $60, so I know that I can spend that much or less. So I'm going to write an inequality that's less than or equal to 60. Now, how do you come up with how do you come up with your costs, Andrew?
35 plus 75 cents.
Okay, so we're going to pay $35 when we walk in the door, and then we're going to, in addition to that, we're going to pay 75 cents every time we ride a ride, so 0.75x. So then therefore, x must stand for, yeah, number of rides. Good. So there's your inequality. All right. Now, what is the maximum number of rides you can go on? We're going to need to solve this to figure that out. So just like solving equations, we're going to subtract the 35. Right? And we're not supposed to be using division yet, but we're going to do it anyway.
Okay,
So 25 divided by 0.75 gets you 33.33. Well, we've got to answer the question. Right, Andrew?
Going a little too fast.
Okay. Okay. And to answer the question in a nice, complete sentence, right? The maximum number of rides is how many? 33. You don't have enough money to get on that 34th ride, right? All right, try the next one on your own. Schools taking students to Kings Island. Okay. So, x plus 27 is less than or equal to 63, where x means the number of students. Now, Taylor went ahead and got us started by solving this, and so we can do that. Okay, it does say write and solve. Okay. And so we get x is less than or equal to 36. So, how many more students can get on the bus? As long as there's 36 or fewer that try to get on, right? Okay? Good? Any other questions here? Got another one. Try this guy. Something like this, hopefully. Okay? Now, if you did an x plus 8 plus 9 is greater than or equal to 25, that's fine too. If you went ahead and added the 8 and 9 and got 17, that's even better. Okay? Okay, so we still have to answer the question, which means we got to solve the inequalities. Just subtract 17 from both sides. Okay? And what are the possible numbers of plants the club can sell on Friday? They could sell how many to meet their goal? 8 or?
More.
Sure. And it's always nice to show that. So we can graph it real quick. All right. Open or close circle on -8. Closed. Left or right? Right. Okay. And there you go. Questions left there?